Hello students, next we will do a problem of supernode analysis with dependent sources. So what we are having here is, in this particular situation or this particular problem, we are having a dependent source, we are having independent sources, and these independent sources are not going to create any big trouble for supernode and all. What's going to create a problem is this dependent source itself, because here we will have to use a supernode. Now again, to refresh your memory, where do we require the usage of supernodes? We require the usage of a supernode when we have a voltage source between two nodes. When we have a voltage source between two nodes, we can't write an equation because here we cannot say what is the current. What is the current that is flowing? We cannot say because we only have the voltage. Because we only have the voltage, we cannot write a KCL equation for V3 or a KCL equation for V2. In such a case, we make what is called as the supernode. So how does the supernode basically look like? You put the nodes together, we put the nodes together and form what is called as the supernode. Now, if there is a supernode like this, then we can do the problem now. So how many nodes are there? There is V1, there is a supernode, and there is V4. Totally, there are four voltages: V1, V2, V3, and V4, which has to be found out. So let us do one by one. First, let us solve this dependent source issue. Now, what is Ix? Ix is basically given by, if you look at the direction of current, Ix is flowing from V2 to V1. This is given. This direction was given in the problem itself. So since it is flowing from V2 to V1, I will write Ix is equal to V2 minus V1 divided by 5 ohms. Okay. So that is done. Another thing is V4. See, we have not drawn the reference. If I draw this one as the reference, we can very easily say from here, and V4 is equal to 40 volt. So two are totally done. Okay, so V4 we have already found out. What is V4? V4, because the 40 volt is between V4 and reference node, and the reference node 40 volt is between V4 and the reference node. So V4 will be equal to plus 40. Why? Because we are having a plus sign here. So V4 is going to be equal to plus 40. So now what remains is for finding out for V1, V2 and V3. So the first thing that we will do is KCL for first node, or what we say KCL at node 1. Okay, so before that I have to draw the current. This I will draw down. This one, let me draw it like this. This is Ix is already drawn. This one I will draw down. This is also I will draw down. Let me draw this one here. So all the branch currents are already given. Here there is no need because it's a voltage source, so no need to draw the current for V4. Okay, so KCL for this one, there are four currents. The first is an outgoing 6 amps current, so minus 6. Then another is outgoing current through 10 ohm resistor, which will be V1 minus 0 divided by 10. Why 0? Because one side it is V1 and the other side it is reference node. This is all reference node. These are all reference node. Okay, so V1 minus 0 divided by 10, which is V1 by 10. Then the third current is incoming current, which is plus Ix, but Ix we have already written as V2 minus V1 divided by 5. So don't forget to put bracket whenever you are having to put bracket. Always remember to put the bracket, because next step when you take, if you have not put the bracket, there is a very good chance that you will make a mistake. So always remember to put brackets. Okay. The next is an outgoing current. So it is minus of V1 within bracket, higher potential is V1 minus V4. V4 is how much? 40 volt. We have already found out, isn't it? Here V4 is equal to 40 volt. So it is V1 minus V4, which is 40 volt, divided by 6, and that is going to be equal to 0. Now I can multiply with 10, 5 and 6, but as you know 5 and 10, 10 is a multiple of 5. So what I will do is, for cancelling 5, I can just do with 10, and then 6 is obviously there. So I will say multiply with 10 into 6. Say I could have written 5 here. I can write into 5. There is no problem. The equation will be different, but the final answer will be absolutely correct. But why am I not writing? Because it's unnecessarily I am multiplying. Generally, I should take only the LCM. That is what is enough. But I don't want to now confuse people by asking them to find LCM. Okay. So if I multiply with this, what will happen is that the denominator will all get cancelled off. Why? Because 10 will cancel with this 10, whereas this 10 and 5 will cancel out, and I will get a 2 on the numerator, isn't it? Why? Because 10 by 5 is going to be 2. So 5 will also go. So there is no need, or there is no point in writing 5 or multiplying with 5 again. So that's why I have avoided it. If you want to write, you can write, there is no issue. The equation will be different, but the final answer will be absolutely correct. You can check it. So I am having 10 into 6. I will always write it as 10 into 6 itself. I don't multiply it, because finally it has to, its job is to cancel out the denominator. Okay. So minus 6 minus V1 by 10 plus V2 minus V1 by 5 minus V1 minus 40 bracket divided by 6. Sometimes I open up the bracket and write, I can write this one as V2 by 5 minus V1 by 5. That makes the problem a little bit easy, but sometimes I don't like it, because I can very quickly calculate, so I don't mind writing it like this. But if you want, you can do that. There is no issue. And this is equal to 0 multiplied with 10 into 6 is 0 itself. Okay. Sorry, let me write that very clearly. It is 0 itself. Okay. So now that is done. So if I multiply with this, what will I get? So minus 360, that is 10 into 6 into minus 6 is minus 360, minus, now 10 and 10 will cancel off, then I will get minus of 6V1, then plus 5 and 10 will cancel off to give me 2, so 2 into 6 is 12, so plus 12V2 minus 12V1, so again denominator is gone, minus 10 into 6, 6 and 6 will cancel off, so I will get minus 10 V1, minus and minus will become plus 40, so plus 40 into 10 will give me 400, and that is equal to 0. Therefore, from which I will get the equation. So now I can directly write what is V1. V1 is minus 6 minus 12, which is minus 18, minus 10, which is minus 28 V1, and V2 there is only plus 12 V2, and we are going to have is equal to 400 minus 360 is going to be 40, which I take the other side, it becomes minus 40. So this is going to be my first equation. Clear? See, some of you, if you do on your own, sometimes you may get 28 V1 minus 12 V2 is equal to plus 40. That is acceptable. Why? Because if I multiply this first equation, if I multiply this equation, this one with minus 1, I will get this equation. So even if I write this equation, or even if I write this second equation, it's all okay. So sometimes the students may get the first or they may get the second one. Generally, the textbooks will always try to achieve it in the second way, but that does not matter. All that matters is that the equation should be correct so that the final answer will always match. Always remember this. The final answer will always match. That's why when people correct the network theory paper, we always go from the answer to the top. Why? Because if the answer is correct, it does not matter comparing the steps, because the steps are going to be different for each and every problem. But if the answer is wrong, then we look at where the steps are gone wrong, and then accordingly the mark is put. So always you must try to see that your final answer should be correct. That will give you 100% marks. Okay, so that is for KCL for node 1. Next we will move for the supernode, because only supernode is there. So KCL at supernode. KCL at supernode. So as you can see, there are 4 currents here. One is V2 outgoing, so it is minus of, within bracket, V2 minus of V2 minus V1 divided by 5. So which all are the currents I am talking about? For this node, this is first current, this is second current, this is the third current, this is the fourth current. There is no other current leaving out of the supernode, isn't it? Only these 4 branches. One is here, one is here, one is here, and one is here. Only 4 branches. Always remember, supernode will encompass, or it will completely put all the nodes in question inside. So I can draw a supernode only like this. Okay, even if I am going to not draw like this, even if I am going to draw something like this, I will have some 6 branches, but again this branch I will not know what is the current, so there is no point in drawing like that. So you can draw the supernode any which way, but the best way is to completely cover all the branches around it, so that you will always get the correct answer. Okay, so minus V2 by V1, that is the first outgoing current. The second outgoing current is minus of V2 by 20, that is this one going down, isn't it? So let me write it properly. So it is going to be minus of V2 by 20, that is the second one. The third one again going outside is minus of V3 by 15, and the last one is again going out of the node, so it is minus of, within bracket, V3 minus V4. V4 we have already seen is 40 volt, so minus 40 divided by, there is no division. Oh, I made a mistake previously. No, it's all correct. Yeah, okay. So it is V2 minus V4 divided by 2 ohms. Sorry, 2 ohms. I should not write ohms. So I will write 2 ohms. So divided by 2 ohms. Okay, is equal to 0. So again we will have to multiply. Now see, if I multiply with 20, even 15 will cancel off. No, 15 will not cancel off, because 20 by 15 is going to give me, again, like with 5 if I go, then 4, 3, it will give me 4 by 3. So I should multiply it with 15, otherwise it won't go. Or I can even multiply it with 30. But again, I don't want to confuse you all, so I will just multiply it with 20 and 15, because 5 will automatically go, no problem. So let me write the equation. So multiply with 20 into 15. Okay, multiply with 20 into 15. I can even straight away take the LCM of 20 and 15 and get the answer as 60. If I take the LCM of 20 and 15, I will get the answer LCM as 60. I can just straight away multiply with 60 and all of this will get cancelled off. But I don't want to again confuse you, but those who have got the idea, they can always try it. Okay, you just need to take the LCM of the denominator and multiply with the LCM, that's all. Anyway, so I'm going to multiply with this, so I will get 20 into 15 multiplied with minus of V2 minus V1 divided by 5 minus of V2 by 20 minus of V3 by 15 minus of V3 minus 40 by 2 is equal to 0. So now when I'm going to multiply, I will get, so 20 and 5, I'll get 4. 4 into 15 is going to be 60. So minus of 60 V2 minus minus becomes plus of 60 V1 minus of 20 will cancel off, so 15 V2 minus of 20 V3 minus of, now it is going to be 20 divided by 2, which will be 10. 10 into 15 is 150, so minus of 150 V3 minus minus becomes plus 40 into 150. So what is 40 into 150? I'll just write 40 into 150. So as you can see, it will be 4,000 and half of that is 6,000. So it will be 6,000. Correct. Is equal to 0. Now for writing V1, V2, V3 separately, so V1 there is only one component, so 60 V1. V2 there are minus 60 minus 15, so that will come out to be minus 75 V2, and then we are having V3 is minus 20 is there and minus 150 is there, so minus 170 V3 is equal to minus 6,000. This is the second equation. So it does not matter, some of them may get a total different equation. Anyway, so once we have done this, so last the equation of the supernode, so voltage equation of the supernode, that is what we write always. So voltage equation of supernode, what is that supernode equation? So we are having 5ix between V2 and V3, so actually I can write V2 minus V3 is equal to 5ix, but 5ix, what is ix? Ix I already found out here is V2 minus V1, so I will basically write V2 minus V1 divided by 5. So 5 and 5 will cancel off, so here I will have this equation. So let me do that in the proper place. So I will rub it here. So it is V2 minus V3. So I will write here V2 minus V3. V2 minus V3 is equal to 5ix, which is equal to 5 times, what was the equation? V2 minus V1. So V2 minus V1 divided by 5, that is equal to V2 minus V1. So from here, therefore V2 minus V3 is equal to V2 minus V1, rearranging, because we have to get it in a simultaneous equation form. So I will bring V1 the other side, so it becomes plus V1. V2, if I take the other side, V2 and V2 cancel off, so it is 0. So 0 V2. So I will just write it for the sake of writing 0 V2, and then minus V3 will remain, and that is going to be equal to 0. So this is going to be the third equation for the unknown. So these are the equations, correct? So based on this, we can very clearly see that if I solve 1, 2 and 3, I will get the answer. Sorry, I have made a mistake here. I should have written here for This one I should have written V3 minus V2 is equal to 5ix. Sorry, I made that mistake. So I will rectify it. So have a look here. So this should be V3 minus V2. Okay, V3 minus V2. So if I rewrite that, V3 minus V2 is equal to, so here also V3 minus V2. Now if I bring V2 the other side, this will become, let me clear it, this will become minus 2V2. This will become minus 2V2. Okay, so now if I am going to do, now I should get the correct answer. So let me again try using the calculator. Sorry, before that I have to put a plus here. V3 is going to be plus here, so this is plus V3. So V1 minus 2V2 plus V3. Then solving 1, 2 and 3, we get V1 is equal to 10 volt, V2 is equal to 20 volt, and V3 is equal to 30 volt. So V4 we have already found out. So I made a silly mistake, isn't it? So you should be very careful while you are doing the problem, because I had to scroll up and down. I made this mistake. Okay, when you are always doing a problem, always start on a fresh page, so that you are always able to keep an eye on what are the values always. Thank you.